At this stage of our course, we are going to introduce the concept of magnetic fields. Previously, you have seen how electric charges create electric fields around it. Similarly, if we have a magnet, it will create a magnetic field around it. You all are familiar with magnets, right? But magnets are not the only objects that create magnetic fields. A moving electric charge can also create a magnetic field. A stationary charge only creates an electric field, but a moving charge creates both an electric field and a magnetic field, which we didn't consider until now. But how these moving charges or electric current create magnetic fields? Well, we'll see that later in our course. So to begin with, let us consider the magnetic fields of a magnet, specifically a bar magnet. You all know that our Earth acts like a giant bar magnet. So let us start with the magnetic field of our Earth. So this is our planet Earth, and the bar magnet of our Earth is slightly inclined with the north and south pole. Okay? Interestingly, you can see that the south pole of the bar magnet of the Earth is actually in the direction of the magnetic north pole, and the north pole is actually in the direction of magnetic south pole. Now, you may ask why this strange convention? Actually, the reason is very much straightforward. As you know, we can find out the north and south by using a compass. So let's say we have put a compass here at this point of the Earth. Now, the north pole of the needle of the compass will be attracted by the south pole of the magnet of the Earth. Okay, this one. So the north pole will align in this direction, and the south pole will align in this direction where the north pole of the magnet of the Earth lies. Now we say this one to be the magnetic north pole because the north pole of the needle points in this direction, and that's why it is opposite to the poles of the bar magnet of the Earth. Okay? And these lines in the magnetic field, we call them the magnetic field lines. They originate from the north pole and end at the south pole. Now we can find out the shape of the magnetic field lines by putting small compass needles at different points around the Earth. Now these magnetic field lines are actually invisible, but we can visualize them by doing a small experiment. So here on the right in this figure, you can see the result of that experiment. So it's a very simple experiment. What we have done is we have taken a small bar magnet, okay, and then on top of that we have put a transparent page, okay, and then we sprinkled some iron filings on top of that. Now those iron filings are attracted by this magnet, and they rearrange themselves according to the magnetic field lines. Here what happens is that each little iron filing acts like a very small compass needle, so that rearranges according to these magnetic field lines. Now if we break this magnet right at the middle into two halves, you might say that we will have a north pole and a south pole. That is, we'll have magnetic monopoles. But the thing is, as you will see from the result of another experiment, that we don't really have magnetic monopoles. When you break this magnet, we still get two magnets with north and south poles. Now, here in this figure, you can see that if we break the magnet right at the middle, we don't have two magnetic monopoles, but instead we have two separate magnets with both the North Pole and the South Pole.